Hey everybody, this is Mr. S, and today we're reviewing the metric system and dimensional analysis. So these are all the different measurements of funny random things that you can measure. So take a minute and pause the video and check this out. It's pretty funny. Alright, so these are all the countries using the metric system for measurement in green. And in pink, the countries that are not using the metric system. So you can see there are only a few of us that are not using the metric system. I don't know why. We won't get into it. But it's important to think about the metric system here, and I really want you to try to take note of this, write it down, and memorize it as much as possible. It's very helpful. You can remember it by saying, King Henry died by drinking chocolate milk. And so these are the measurements of mass, weight, and volume. Meters for distance, gram for mass, and liter for volume. So these are kind of the universal meters. And so the largest that we'll look at is kilo. So like a kilogram, a kiloliter. Surely you've heard of that. And then a hectometer, hectogram, and a decagram. So you can remember these little abbreviations, and it will really help you in life and in this class. And then when you're getting smaller, you'll go down. So you'll go from decimeter or decigram to centimeter to millimeter. Okay? Now, all you need to do to convert these is to move the decimal, okay? So let's say you have a meter and you want to go to a centimeter, so you have 1 meter, and you want to go to a centimeter. If this is 1, the decimal's here, right? So 1 meter is 1, 2. We move the decimal 2 points. So that would be 100 centimeters. And if we want to go to millimeters, 1 more. So it's 1,000. 1 meter is 1,000 millimeters, or 10 decimeters, or in the other direction, if we have 1 meter, it would be 0.1, if we go this way, decameters, or 0.001 kilometers. So this is a really handy way to think about it and be able to convert a lot of the metric system measurements. Okay? Alright, and then here's some more examples of that. If we have 1,123 milligrams, that is 1.123 grams. And try these out. You can pause the video and try them out to test your knowledge. Make sure you get it. Write it in your notes. 14 kilometers is how many meters? 14,000. All right. 1.2 liters, 1,200 milliliters. So on and so forth. So you can test yourself in the video, pause the video, and try these out. You can rewind the video too. Okay, so most of you should have done this in chemistry, but dimensional analysis is about conversion. Okay, so converting from one set of units to another. And this is something you will often have to do in real life. So remember, anything you measure will have a number with some sort of unit of measure, the dimension attached. A unit could be miles, gallons, miles per second, P's per pod, or kilowatt hours per year. And so in dimensional analysis, the equivalents are expressed as a ratio. So see the yellow and blue here. These could be known equivalents, either from prior knowledge, like 1 meter is 100 centimeters, you just know that, or it could be provided to you on a problem with specific equivalents. Like it might say, each farmer can use 30 pigs on his farm. So that would be 30 pigs per farm. right? So I want you to think about this line as, this is per, so 60 minutes per hour, 1 yard per 3 feet, okay? Or 60 minutes for every hour, okay? So if you feel that if you need more review, I would look this up on Khan Academy, but these are also some really common conversions that if you don't know these off the top of your head, you might want to jot some of these ones down and just kind of study them. All right. So an important real-life problem that requires dimensional analysis here, okay? So try to pay close attention to what's going on here. And how did Indy know how much sand to use? Because obviously he may not have done the best job. Oops. Let's watch. Okay, so in the Raiders of the Lost Ark, Indiana Jones tried to remove a gold idol from a booby-trapped pedestal, as we just saw. He replaces the idol with a bag of sand. If the idol has a mass of 2 kilograms, how many liters of sand must he place on the pedestal to keep the mass-sensitive booby trap from activating? And you know the density of sand is 3 grams per centimeter squared. So the first thing you want to do, and take notes on this, the first thing you want to do is write down the units that you want in your final answer and put a box around this. Okay, so we want to know how many liters of sand are in one idol. And then begin your conversion with a unit in the numerator on top that you want in your final answer. Okay, so we want liters. So we'll start with 1 liter. And now we're going to come up with a liter equivalent. So we know that there's 1,000 milliliters in 1 liter. So that will take us to the next step, right? And then now that we've set up the conversions so that each denominator is canceled out with the next numerator until you finally have the denominator you want in the final answer. So we're just going to keep canceling them out until we get the proper units, okay? So we have 1 liter per 1,000 milliliters. And we know 1 milliliter is 1 centimeter squared. So that gets us to liters over centimeters cubed. Okay? That's a volume. And then we know 1 centimeter cubed is 3 grams. So we can use that unit to measure. And you can use any ones you want, but it'll start to make logic sense how you set it up so that the units cancel. And then 1,000 grams per 1 kilogram. That will finally cancel. And then you finally get 2 kilograms per idol, right? And that cancels. So take a second and really think about this, draw it out, think it through, how we got to this. But basically we set up the answer we want to get, the units, and then we convert it step by step to get to the final unit that we want. So the final step is, then we have to complete the multiplication across the top and bottom and then divide if needed. Remember PEMDAS. Everyone should know that by now. So 200 divided by 3,000 is 0.667 liters of sand, which is the weight of the idol. And this is how you just divided everything on top and multiplied everything on top and everything on bottom. Okay, so you don't really need to worry about the actual numbers until the very end. Just focus on the units. So the good thing about APES math, environmental science, is that it's real life situations. So you always have to ask, does my answer make sense? If you found that my family is paying $3 million a year for electricity that a farmer is growing a month, you know you made a mistake. You could think about a 2-liter bottle. You know, could you compare this to make sure it makes sense? Okay, that's all for this first video on dimensional analysis. We'll see you next time.